Traditional corporate structures have reached a physical limit. Decades of applying efficiency gains to human-centric hierarchies can no longer absorb the escalating speed of global commerce. For legacy manufacturing and engineering firms, this limit manifests as a structural performance gap that threatens their standing against international, tech-driven competitors. This chart details the gap's exact metrics: a 30% price disadvantage and 25% time-to-market lag compared to global standards. Standard updates are mathematically insufficient here. As indicated, overcoming these deficits requires a deep redesign of the value streams themselves. Closing this gap necessitates a transition away from traditional top-down hierarchies toward an AI-native architecture designed for high-speed execution. In the global AI race, tech giants in the US and China dominate the foundational layer. They possess the massive GPU compute and billions in capital required to build baseline models. Legacy industrial firms cannot and should not attempt to fight a capital war at this infrastructural level. This diagram illustrates a more viable strategy: leapfrogging. The German advantage lies in dominating the application layer. By integrating excellent research, proprietary domain data, direct customer contact, and deep engineering expertise, a firm creates a defensible competitive moat. The firm's value now centers on deploying engineering logic to orchestrate autonomous digital value streams, with physical production acting as the final step in a digital chain. Forcing high-speed AI capabilities into a legacy management structure creates immediate bottlenecks. The human approval chain simply moves too slowly to handle machine-speed data. The structural solution requires replacing the corporate hierarchy with a decentralized network of interconnected nodes. This network maps the new reality. Purple nodes represent AI agents handling high-speed data, error correction, and transactions. Humans move out of execution. Gold nodes are human orchestrators, strictly confined to strategic governance, empathy, and ethical decision-making. The organization functions as a shared agency, a synchronized orchestra where human intelligence dictates direction and machine capacity handles the scale. AI assumes the administrative functions previously handled by middle management, allowing the organization to operate without the delays of manual reporting. Because AI agents handle administration, scheduling, and optimization autonomously, traditional roles built around human resource management become obsolete. This demonstrates the necessary shift in leadership. Chief Human Resources Officer is crossed out, replaced by the Chief Node Officer. Responsibility moves to governance. Every AI action must be tethered to a human orchestrator, ultimately accountable for ethical constraints and accuracy. Leadership transitions from managing human tasks to engineering the strategic parameters of autonomous systems. Moving from theory to execution requires a specific operating system to run this node network efficiently. This flowchart maps the Edge team operating system. It relies on 7 pillars of autonomous value creation, with our focus resting here on the specific HR AI node. Consider an 800-employee manufacturing firm struggling to acquire engineering talent. The firm sets a target time to hire of 35 days. However, internal tracking shows their actual process is lagging significantly, taking 52 days to fill a single role. This 17-day delay triggers compounding operational damage. Recruitment costs spike, engineering teams grow frustrated, and faster competitors poach top talent. These process bottlenecks inflict severe, quantifiable business costs. Human HR teams, relying on manual screening and email follow-ups, cannot process data fast enough to reverse the trend. To solve this, AI agents replace static dashboards with continuous decision cycles known as the OODA loop: observe, orient, decide, and act. This interface is the AI recruiting orchestrator. The process begins with human-defined inputs: the exact role, salary targets, necessary skills, and the specific context of the current 52-day delay. In the observe and orient phases, the agent analyzes historical hiring data and identifies the exact manual bottlenecks stalling the evaluation stage. Moving to decide and act, the agent formulates a priority strategy and autonomously executes a revised recruiting pipeline. This dashboard displays the agent's output. In seconds, it establishes rigid service-level agreements for each phase, initiates proactive candidate sourcing, and scores market talent. By utilizing the OODA loop, the AI agent converts a chronic, structural delay into a precise, high-speed automated transaction. This HR agent functions as the initial, validated building block of a comprehensive cognitive enterprise. Expanding this automation across engineering, sales, and supply chain requires a strict, non-negotiable architecture of collaboration. This diagram outlines that collaboration. The feedback arrows show synthetic roles handling heavy execution and data processing, pushing structured insights upward. The human orchestrator sits at the top, their function exclusively to validate synthetic outputs and adjust targets based on real-world friction. Enterprise automation isolates human value, dedicating their entire bandwidth to strategic judgment and proprietary domain expertise. Over time, this architecture creates a compounding advantage that scales across the entire company. This timeline charts the evolution from a Stage 1 human-centric model into a Stage 3 agentic enterprise. The expanding gap between these curves represents effective IQ, the mathematical multiplier created when legacy human expertise is combined with synthetic execution. This scaling intelligence directly targets the initial threat, neutralizing the 30% price disadvantage and closing the time-to-market lag. A legacy firm architecting this node network scales proprietary engineering expertise at the speed of software, effectively neutralizing the global performance gap.